This is the first video for college algebra in context with applications for the managerial, life, and social sciences, and this is out of the 5th edition. There's the picture of the book there so that you know that you have the right textbook. And this is 1.1. Now I'm assuming that as we get started in 1.1 and 2.1 and 3.1, etc. throughout the book, that you are looking at the toolboxes, which is at the beginning of each chapter. In fact, this one starts on page 2 and is called an algebra toolbox. And it reviews for you sets and ways to algebraically write the sets as far as real numbers, what the null set is, what infinite and finite sets are, what disjoint sets are, how to write your sets as inequalities and intervals on a number line. Important stuff that I'm assuming that you know because you've gone over and looked at the toolbox at the beginning of this chapter. So that takes us to page 10, where we're talking about functions and models. Now, functions are going to be a key piece of college algebra, as well as if you continue on and get into calculus. Functions are very, very important to understand. Yet, they aren't that terribly complicated to understand. So actually, if you look at the top of page 11, in the green box there where it says a function, it pretty much gives you a definition of what a function is, and then I'll go into a little bit more detail about it because sometimes the definitions in the book are a little bit abstract, a little bit hard to understand. So let's look what it says. A function is a rule or a correspondence that assigns to each element of one set, called the domain, exactly one element of a second set, called the range. All right, so let me give an example here. So our domain, let me get a pen that works. Domain starts with a D, and range starts with an R. And the reason I say that is because the domain is your input, your range is your output. It's what you're getting out of it. Okay, X comes before Y, D comes before R. That's how I remember which one I'm looking at as far as the domain and the range. All right, and what that is saying is one element, 6, will, let's say that we have as our equation or our expression x plus 3, okay? So when we put 6 in for x, it's going to spit out a 9. When we put a 4 in for x, it's going to spit out a 7. Notice that no matter what number we put in for the x value, it will give us a y value, one y value, exactly one element. I cannot put a 6 in this equation and get a 9 and a negative 9, okay? It's not possible. There are some times where it is possible to have an equation that'll give you two different answers, but in this case, that doesn't happen. So therefore, we call this a function because one element is put into the equation and it spits out one other number, one other element here, exactly one. It does not give us two. If it gave us two elements, let's say this gave me a 6 and or a 9 and a negative 9, then this would not be a function. When we graph it, we'd be able to look at it and say, no, it's not a function, because the 6 corresponds to two numbers rather than exactly one. So let's look at the table 1.3 in the middle of page 10, where they give us Celsius and they give us Fahrenheit. And there is a formula to switch from Celsius to Fahrenheit, and that is 9 over 5C plus 32. So that means that if we take a number like negative 20 for Celsius, and we put negative 20 in there, multiply it by 9, divide it by 5, and add 32 to it, our Fahrenheit temperature is going to be negative 4. Okay, so it does not matter what number we put in there. Let's put in -10 so I can look at the table on the book, and it'll give us a 14. So any number that we put in here for C will spit out one and only one element of Fahrenheit. You cannot say that it's -20 degrees Celsius and get a Fahrenheit temperature that is two different numbers. Where, well, yeah, it's -4 Fahrenheit, or it could be -47 degrees Fahrenheit. No, you don't get two answers. You get one answer, okay? And if you notice the graph on the left-hand side of the page, figure 1.5, it shows you as they graph those points from table 1.3, it gives you a straight line, okay? So a straight line that is not vertical or up and down will always be a function, and that's where we are at this point. We've got a function there. Now we're not going to do example 1 on page number 11. I'm just going to kind of go over with it just to make sure you have a good understanding of it. Okay, so we got this kid's temperature, and the normal temperature is 98.6 degrees Fahrenheit, but the only thermometer we have is one that is in Celsius. Now, why in the world would you have a thermometer that's in Celsius when we read Fahrenheit here in the United States? But anyway, it's a story problem. You kind of make things go that way. And it indicates that the child's temperature is 37 degrees Celsius. So what they're asking us to do is, does that 37 degrees Celsius indicate that the child's temperature is normal, 98.6? So what we do is we just take our formula. Fahrenheit equals 9 over 5 C plus 32. We put 37 degrees in there for C and solve it, and we get 98.6 degrees Fahrenheit, and yes, that is normal, so we're good. Okay, so let's look at domains and ranges for a minute. So I had mentioned earlier that the domain was basically the x coordinate. It can be the y, but for the most part, what we're going to run into is it's the one we start with, and that's usually the x variable. So the domain is going to be along the x-axis normally. So if you look at figure 1.5, the degrees Celsius, our input is Celsius, so it's on the x-axis there. Our output, what we get for an answer, would be our y, and that would be our range. We also are dealing with a couple terms here, independent and dependent. Now, independent would be, the independent variable would be the variable that really we start out with. Independent means it's all on its own. It doesn't depend on anything else. We can make that number anything we want. It's independent of the equation or anything else going on in the world. The dependent variable, on the other hand, usually the y variable, is dependent on what's going on. The range is normally dependent on whatever the x value is. So let me give you an example. Let's look at something simple like x plus 3. What is my x? I can call my x any number in the whole wide world, in the history of the universe I want. Okay, so let's call it 7. Can I call y anything? No, because y is dependent on whatever x is. If x is 7, y has to be 10. If x is 0, y has to be 3. So do you see that the y variable, the output, is dependent on what the input is. Okay, so the input is independent, the output is dependent. Okay, there is another way of writing the dependent variable, and the dependent variable can be written, and you've probably seen this before, as f of x. Okay, basically function of x, but it's just quickly read as f of x. It's, gosh, for all intents and purposes, it's just another symbol for y. So instead of using y, we're going to use f of x. Okay, so when you make this little table here where you have an x and a y, and if you put a 3 in here and it spits out a 4 or a 5 and it spits out a 6, etc., instead of writing it that way, we just write it like this. And it's pretty much all the same for what we're doing here. Okay, so f of x, it just means my y value, it means my dependent value, it means my output, what do I get for an answer, and you should be okay. All right, so let's jump up to example number 2. Okay, so for example 2, it's just asking us to find the domain and the range. So really what you're going to do is you're going to look at A, and you're going to write the coordinates of A. So you've got -5, -7. We've got -3, -2, -1, 6, 0, -2, 3, 5, 5, -7. Okay, so the domain would be the x values. The range would be the y values. You're done. That is it. The only thing I would say is notice that on our y values here we have a -7, here we have a -7. You don't have to write those -7s down. If it repeats itself, just write it one time and you're fine. Okay, so let's look at B. B is a little bit different because A had just dots on there. Here we have an entire line here. So that means every single stinking point between here and here are on the x-axis, or are part of the domain. And there's an infinite number of points here. So what we've got here is we've got all the points between -3 and +3. And it also includes the -3 and the 3 because the endpoints are solid. They're not open. So that means it includes the -3 and 3. All right. Thus, the domain can be written as oops, let me get my pen again. -3 is less than or equal to, our x is less than or equal to 3. Sorry about my golden retriever puppy deciding to bark on us there. We can also write this as interval notation of -3 and 3, and put that box there. So remember the square parenthesis, if you want to call it that, means it includes both numbers left and right, and a round one means it does not include those numbers. So anyway, that would be the domain, and the outputs then would be every x that we put in. So any x we put in is going to give me a y value. So if I'm at 2, if I go to 2, my y value is going to be up here around 5. But anyway, it's not going to go any higher than 40, nor is it going to go any lower than it looks like maybe -27. The book says -27 and 39, but you can't really tell that from a graph. So I'm just going to put 30 there. Or I mean, should be 40, shouldn't it? 40-ish. So it should be -27, less than or equal to y, because we're dealing with range there, less than or equal to 40. Interval notation, -27 inclusive and 40 inclusive. Okay, now so looking at C, you notice that it heads this way along that x-axis into infinity, and it's also rising higher and higher from the x-axis, so it's also going in an up position into infinity. So the domain would be x is less than or equal to 4, because it starts here and is any number to the left into infinity, so it's all numbers less than 4. Or if we want to write it in interval notation, we can make the little infinity symbol, 4 and a square there. Notice that it's rounded, always rounded on infinity, because you never get there. It never includes the number infinite because it doesn't exist. So it's always rounded there. And our y value then starts at 0, And so it's going to be greater than, any number actually greater than 0, and it's going to go up into infinity. So it's going to be 0 inclusive up to positive infinity rounded. Okay? So that's 1.1a video, and I'm going to shut this down and start a new video, 1.1b as in boy, for you to continue on with this lesson.